Hey guys, welcome. We'll continue our introduction to cryptography room on TryAppMe. Today we'll be moving to task 2, which is the symmetric encryption. So it will require me to start my attack box. So I'll do that now. By the time I reach the task exercises, the attack box would have been completely loaded. Let's review some terminologies. Cryptographic algorithm or cipher. This algorithm defines the encryption and decryption processes. What do we mean by algorithm? Those are a set of rules or conditions a particular task is set to. Another thing you can do is just to type algorithm definition. And we are going to have a simple definition here. It says a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. So in case you're wondering what an algorithm means, it just means set of rules to be followed by a machine. Good. Let's move on. A key. The cryptographic algorithm needs a key to convert the plain text into cipher text and vice versa. The plain text is the original message that we want to encrypt, and the cipher text is the message in its encrypted form. What do we mean by symmetric encryption? A symmetric encryption algorithm uses the same key for encryption and decryption. Consequently, the communicating parties need to agree on a secret key before being able to exchange any messages. In the following figure, the sender provides the encrypt process with the plain text and the key to get the cipher text. The cipher text is usually sent over some communication channel. As you can see, we have the plain text with the encrypt and we have the key, then the cipher text. On the other hand, the recipient provides the decrypt process with the same key used by the sender to recover the original plain text from the received cipher text. Without the knowledge of the key, the recipient won't be able to recover the plain text. National Institute of Standard and Technology (NIST) published the Data Encryption Standard (DES) in 1977. DES is a symmetric encryption algorithm that uses a key size of 56 bits. In 1997, a challenge to break a message encrypted using DES was solved. Consequently, it was demonstrated that it had become feasible to use a brute force search to find a key and break a message encrypted using DES. So in 1998, a DES was broken in 56 hours. These cases indicated that DES could no longer be considered secure. So the NIST published the Advanced Encryption Standard (AES) in 2001. And like DES, it is a symmetric encryption algorithm, meaning you use the same key to encrypt to decrypt. However, it uses a key size of 128, 192, or 256 bits. Don't forget 8 bits equals to 1 byte. And it's still considered secure and in use today. AES repeats the following 4 transformations multiple times. So there are 4 things that it does multiple times to be considered secure, to make the process secure rather. We have the sub bytes, the shift rows, the mixed colons, and the add round key. So source byte, this transformation looks up each byte. Don't forget 8 bits equals to 1 byte in a given substitution table, that's the XBus, and substitute it with the respective value. The state is 16 bytes, that is 128 bits, saved in a 4x4 array. It's like we have like a matrix, a 4x4 matrix. Now let me give you this like example now. This is a shift row. Okay, let me explain what a shift row is. A shift row, the second row is shifted by 1 place, the third row is shifted by 2 places, and the fourth row is shifted by 3 places. This is shown in the figure below. For this now, okay, let me hide my attack box. Good. So now we have this is our first row is in first place. The second row is shifted by one place. The third row is shifted by two places, and the fourth row is shifted by three places. So when we are having the output, the first row remains 0, 0, 0, 1, 0, 2, and 0, 3. That's the Xbox. So because we've shifted the second row by one place, it's going to start by 1, comma 1. Then the next thing is 1, comma 2, then 1, comma 3, then we come back to 1, comma 0. The third row, it has been shifted by two places. So we start with 2, comma 2, followed by 2, comma 3, followed by 2, comma 0, followed by 2, comma 1. Then the fourth row, we've shifted it by three places. So we are having the 3, comma 3 first, followed by the 3, comma 0, 3, comma 1, and 3, comma 2. That's how shift rows works. The mixed columns. Each column is multiplied by a fixed matrix. You know, the same way we do like 4 by 4 matrix. Okay, let's not get it complicated. Just know that if we are having a mixed column state, we are multiplying by a fixed matrix. Then we have the add round key. A round key is added to the state using the XOR operation. I think I explained that in the previous video. I think the first video on cryptography, yes, introduction to cryptography. So now, the total number of transformation rounds depends on the key size. Don't forget that it does this different transformation multiple times. So depending on the key size, that determines the number of times it's going to do the transformation rounds. So don't worry if you find this cryptic, because it is. The purpose here is to learn, is not to learn the details of the AES. It's not to learn how it works, actually, just to have an idea so that we can understand what is happening in the background. So the purpose is to appreciate the difference in complexity between ancient encryption algorithms and modern ones. So if you are curious to dive into details, you can check the AES specifications, including pseudocode and examples, in its published standard. Okay, so we have resources there. And in addition to AES, many other symmetric encryption algorithms are considered secure, and there is a list of symmetric encryption algorithms supported by the GPG. Okay, this site can be reached. Wow. Okay, so we have the AES 192 and AES 256. We have the IDEA, which is the International Data Encryption Algorithm. We have the triple DES, which is the Triple Data Encryption Standard. We have the CAST5. We have Blowfish. We have Twofish, Camellia 128, 192, and 256. Now, all the algorithms mentioned so far are block cipher symmetric encryption algorithms. Excuse me. So, excuse me. Don't forget that symmetric encryption means that the same key that is used to encrypt is what is used to decrypt. A block cipher algorithm converts the input into blocks and encrypts each block. A block is usually 128 bits. So in case you are wondering what a block cipher is, that's what we are explaining now. We already know what an algorithm is, which is a set of rules. We know what encryption is that means converting plain text to cipher text. We know what symmetric encryption means. It means when you want to convert a plain text to a cipher text, you are using the same key that you use to convert the plain text to cipher text. When you need to decrypt it, you are going to use that same key to decrypt it. Now, what is a block cipher? A block cipher algorithm will now convert, in the process of trying to convert plain text to cipher text, it first converts that plain text into blocks. It will now encrypt each block. So a block is usually 128 bits. And in the figure below, let's see an example. Let's say we want to encrypt the plain text Tango Hotel Mike, a total of 16 characters. If you are wondering why it is 16 characters, it's because of the space bar. The space added is considered a character. See, Tango 1, 2, 3, 4, 5. The space 1 character, which is 6, 7, 8, 9, 10, 11. The space 12. Mike 13. Excuse me. 13, 14, 15, 16. So we are having a total of 16 characters here. The first step is to represent it in binary. Now let's focus on this picture. We have our 16 characters here, and we are going to convert each one to a binary. T is converted to 54. If we use the ASCII, then T is 54 in hexadecimal format. So we are using the X format here. So T is 54, A is 41, N is 4E, G is 47, 0 is 4F, and the space 20, H is 48, and so on like that. Now, every two hexadecimal digits constitutes 8 bits. Every two. So this 54, every two hexadecimal digits constitutes 8 bits, and 8 bits equals to 1 byte. So this 54 is 8 bits, and we are having it as 1 byte. And a block of a block of 128 bits is practically 16 bytes. That means we are having 16 hexadecimal digits, and is represented in a 4x4 array. So you know when you have a 4x4, that means you have 16 characters there. Yeah. So the 128-bit block is fed as 1 unit to the encryption method. So now if we have this that has been converted to our X and we put it in a block, don't forget we are using a block cipher. So this is how we arrange it: 54, 41, 40. So it goes this way. You can see the arrowhead. The arrowhead just points the direction with which it goes. So when it is encrypted, we have our cipher text. So that's what a block cipher is all about. The other type of symmetric encryption algorithm is stream ciphers. Don't forget, we talked about block cipher. We're talking about stream cipher. Just to reiterate, algorithm is a set of rules. Encryption is a method of converting plain text to cipher text, right? Now we have two types, the symmetric and the asymmetric. For the symmetric, we are using the same key to encrypt to decrypt. Now we have two types. We are discussing two types now, the block cipher and the stream cipher. For the block cipher, the plain text is converted to blocks and it is now encrypted. We are moving on to the stream cipher. Now, the stream cipher will encrypt the plain text byte by byte. Now, let's consider the case where we want to encrypt this same message, Tango Hotel Mike, using the stream cipher. Each character needs to be converted to its binary representation, like we did if we use ASCII, that is an hexadecimal. We are having T equals to 54 as above. So the encryption method will process 1 byte at a time, and which is represented in the figure below. Just 1 byte. Don't forget, these two characters is 8 bits, which is the same thing as what 1 byte. So it picks one, encrypt, picks another one, encrypt, picks another one, encrypt. Unlike this one that picks the blocks and encrypts, it encrypts the whole block. Good. Now, symmetric encryption solves many security problems discussed in the security principles room. So let's say that Alice and Bob met and chose an encryption algorithm and agreed on the specific key. We assume that the selected encryption algorithm is secure and that the secret key is kept safe. Let's look at what we can achieve with this. First, we can achieve confidentiality. That means if Eve, who is a third party, intercepted the encrypted message, she wouldn't be able to recover the plain text. Why? She does not have the key. Consequently, all messages exchanged between Alice and Bob are confidential as long as they are sent encrypted. Integrity. When Bob receives an encrypted message and decrypts it successfully using the key he agreed upon with Alice, Bob can be sure that no one could tamper with the message across the channel. When using secure modern encryption algorithms, any minor modification to the ciphertext would prevent the successful decryption or would lead to gibberish as plain text. What it means is that after the plain text has been encrypted and sent over a communication channel, peradventure there was a breach and the ciphertext was modified. The moment it gets to the receiver and the receiver is trying to perform a decryption, whatever is going to come out is going to be gibberish or to be unsuccessful because it has been tampered with. The key is not just going to give you a successful output. On to the next one, authenticity. Being able to decrypt a ciphertext using the secret key also proves the authenticity of the message because only Alice and Bob knows the secret key. So it means that this message was definitely sent by Alice. We are just getting started. And we know how to maintain confidentiality, check the integrity, and ensure the authenticity of the exchange messages. More practical and efficient approaches will be presented in later tasks. The question for now is whether this is scalable. With Alice and Bob, we need one key. If we have Alice, Bob, and Charlie, we need three keys. One for Alice and Bob, another one for Alice and Charlie, and the third one for Bob and Charlie. However, the number of keys grows quickly. Communication between 100 users requires almost 5,000 different secret keys. Now, if you're curious about the mathematics, just do the mathematics 99, 98, 97, like that. I had it up to 1, and we have our answer. Moreover, if one system gets compromised, they need to create new keys to be used with the other 99 users. Another problem would be finding a secure channel to exchange the keys with all the other users. Obviously, this quickly grows out of hand. In the next task, we'll cover asymmetric encryption. One of the problems solved with asymmetric encryption is when 100 users only need to share a total of 100 keys to communicate securely. As explained earlier, symmetric encryption would require around 5,000 keys to secure the communication for 100 users. There are many programs available for symmetric encryption, and we are going to focus on two that are widely used. These two are also used for asymmetric encryption. We have the GNU Private Guard and the Openssl project. The GNU Privacy Guard, also known as the GNU PG, implements the OpenPGP standard. So let's see what the GNU Privacy Guard is about. You right click. Okay, I think our encryption standard is out. It's just the abstract here. Okay. Yeah, defined by, okay. So in cybersecurity, we have a lot of studying to do really. The more you think you know, the more you think you know, the lesser you find that you know. Okay, think, okay. So you can see pretty good privacy. So PGP means pretty good privacy. You can see that is a family of software systems developed by this person for which OpenPGP is based. That's a lot of documentation. And okay, let's move back. Let's not lose focus. If you need to read, just read more on that. So we can encrypt a file using the GNUPG, that is GPG, using the following command. We can see it a GPG, symmetric cipher algo, then the cipher, the message.txt. Where cipher is the name of the encryption algorithm. You can check supported ciphers using the command gpg-version. The encrypted file will be saved as message.txt.gpg. Let's show our attack box now. Show split view. We're going to click on that. Now attack box is going to come up. But all these will not be abstract. So where cipher is the name of the algorithm. Okay, we're going to open a terminal. I'm going to check what, just try it open right here. We are the roads. Okay, so GPG. Oh, okay, first, okay. So that's the cool thing about Triac. You don't have to load up So we can see the algorithms it supports. We have the IDA, triple DES, Cas5, Blowfish, AES 192, 256, two fish. So we can see the hashing algorithm that it supports too, and the compression algorithms. You can also see the public keys that is applicable to that are applicable rather. So this is the format with which the encrypted file is going to be saved as .txt.gpg. Now the default output is in the binary OpenPGP format. However, if you prefer to create an ASCII armored output, which can be opened in any text editor, you should add the option --armor. For example, GPG, armor, symmetric, sulfur, igo, cipher, message.txt. And we can also decrypt using this command. As we change GPG, we have output, then we input the original text, we put the decrypt option, and we put message.gpg. That's the name of the output you are trying to. So the other project is the OpenSSL project. So don't forget, the first thing is GNU Privacy Guard, that is based on Pretty Good Privacy, that's the PGP, and the OpenSSL project that maintains the OpenSSL software. So let's open this. We can encrypt a file using OpenSSL using the following command. We have the OpenSSL AES256, that's the encryption algorithm that is being used, obviously. Then we have the other syntax, message.txt, out encrypted _ message. And we can also decrypt using this following command. Now, to make the encryption more secure and resilient against brute force attacks, we can add the -pbkdf2 to use the password-based key derivation function too. Moreover, we can specify the number of iterations on the password to derive the encryption key using this iter number. So to iterate 10,000 times, the command will just be iter then 10,000, like that in the syntax. Consequently, the decryption command becomes OpenSSL, the AES256-6BC, the same iteration that you had there for the encryption. Now, instead of E, we'll be having D as in decryption. Then we input the encrypted message, that's the name of the file. Then we out into the original message text, that's the name of the new file. So in the following questions, we will use GPG and OpenSSL on the attack bus to carry out symmetric encryption. All this can actually be done with some web-based GUI web app rather, with some web app. However, I'm just trying to do it with the command line. It's not every time you may want to use the. I believe everyone should have access to security and privacy tools. Okay, sorry for the distraction. The necessary files for this task are located under this directory, and the zip file attached to this task can be used to tackle the questions of tasks 2, 3, 4, 5, and 6. So what they mean is that in case you don't want to use the attack bus, you can just download this file and you do what you're asked to do from your own laptop. However, I'm going to use the attack box here, and we've been told where to find the files. So let me just navigate to the file. Okay, roots. I think I'm in roots. Rooms. Cryptography intro. Task O2. So now we are in this room. Let me ls. Oh, okay. So we have all the files that we need for task 2. I already navigated it to make it very easy for me. So we've been told, why are you disconnected? Please don't disconnect. We've been told to decrypt the file _01 encrypted using this AES256 with the key using GPG. What is the third word in the file? I don't expect you to memorize the syntax yet. It's not what you use every day. However, it's good to have your own like cheat book where you put all your necessary command. It could be soft copy, it could be hard copy. So we've been told to decrypt the code 01. I've been told the encryption algorithm that was used. So we are going to find this is code 01.txt.gpg. That's to show that it has been what? Encrypted. So now we are told to use GPG. Let's come for the syntax for decrypting GPG. So we are going to do, okay. Okay. What is the third word in the file? So we are doing GPG, right? Outputs, the original message dot txt. That's where we want it in. So it's code 01. I'm going to type code 01.txt. That's the name of the file I want the plain text to be in. Good. Then we do decrypt. We want to decrypt code 01.txt.gpg. I hope you understand what I'm trying to do. .txt.gpg. Enter. So it's going to ask us for the key that has been provided. As you can see, we have S, exclamation mark, then we have small letter K, capital letter R, 3, capital letter T, 55, and we enter. So we have AES256 encrypted data, encrypted with one passphrase. So I'm going to list, we should have a new file here that says code1.txt, right? So I'm going to, is it echo now? I'm not sure. Codes, or is it cat? I'm supposed to cat rather. Cat codes 01.txt. We're going to have the output. So we are asked, what is the third word in the file? 1, 2, 3, waste. Waste. And we are good to go. Whew. Let me go over this again so that you'll not be confused. First off, we're told where our necessary files are. So the best thing to do, the easiest thing to do is to navigate into that folder where our files are. If not, for every command you send in Linux, you have to input the file path for that file so that you can get to the location of the file. If a file is in tax02 and I'm in desktop and I'm inputting my command, it most likely will tell you that the file is not found because that's not the directory with which it is if you did not provide the file path, right? Yeah. So the first thing to do is to navigate into the file path where the file we want to work with is. Good. Then we're told to decrypt using GPG. We already have our syntax for GPG, and the syntax is the GPG. Now we want to output a new plain, not a new plain. We have the ciphertext that we want to convert to a plain text. So the next command we throw at it is output. Right. Now we give the new text a name. Don't forget that the ciphertext is what? Code 01, and we're told that for every file that is encrypted, it will have a .gpg at the end. So the best thing is this code 01.txt.gpg is our encrypted file. So I would just name the original text that we are trying to get as code 01. I don't know why this thing is disconnecting. So now that I've named it quote 01, the next thing to do is to throw the command at it. Continue the syntax as it has been written. So we tell it that we want to decrypt. We throw the command decrypt. Then we now tell it the file that we want to decrypt, which is quote 01.txt.gpg. So once we do that, it gives us an output and asks us for the passphrase or password. And we've been provided with the key. That's just basically the key. We put the key and it has been encrypted. So once I do the ls I'm putting, I'm asking it to list all the files in that folder. And I could see that quote 01.txt that I created has been added to that folder. I hope you are getting me. If you are not getting me, or if you feel, just take your time and listen and pay attention. So now we have the quote 01 text proving that there is successful decryption. Now I need to read the content of quote 01.txt. So I use my cat command. So the cat command is going to output the content of that file onto the screen for me. I don't have to use a text editor. You can also use a text editor to open it, which is fine. So the cat command sends out my output to the screen and I get to read it. Do not waste time idling or thinking after you have set your goals. Miyamoto Musashi. And the question said, what is the third word in the file? The third word in the file is waste. So that's how we do a decryption using GPG. The next question. Decrypt the file code 02, which has been encrypted with AE256 CBC with a key using Openssl. What is the third word in the file? Now this one was encrypted using Openssl and we're told that it is code 2. As you can see, we have a code 2. Can you see? That's it. Good. We are supposed to decrypt this. We come here for the command to decrypt the file using SSL. And this is it. Openssl AES 256 CBC. So if another encryption algorithm was used and it has been mentioned, we are going to write that encryption algorithm instead. Now, we are not sure if PBKDF was used, right? So we are not going to do that. We're just going to do the regular thing if you need to decrypt. So the next thing to do is -D. That shows that I want to decrypt. And we are going to put the, in. Good. Then now the encrypted message, which is what? Quote 02. Quote 02. Good. Then we've been told that we want to output that -out. What do we call this one? Just call it quote 02.txt or any other thing you want to call it. Quote 02.txt. Great. Are we fine? Thank you. Then we press what? Enter. It's asking for the password. The same thing we did. This password may not show because it doesn't really show. Just make sure you are typing it correctly. S, then exclamation mark, small letter K, capital letter R, 3, capital letter T, 55. Enter. So warning, deprecated key derivation used. Good. So this has told us that the decrypted key has been used. So we have to use the word decrypted key command. Am I making sense? Okay, so this one has been used to prevent what? Brute force attack. We are going to do our command again. Okay. Just press the upper arrow button and you have all your previous syntax. So you don't have to type everything all over. Go to CBC. Then we type dash pbkdf2. Let's see. The question password. Small letter S, exclamation mark, K, capital letter R, 3, shift T, 55. Enter. Okay, bad decrypt. Okay. Let me see ls. Will it come out? Let me just remove it. Let me see parts codes o2.txt. I don't know why I'm having. Oh wow, it's really bad. So I'm going to do it. I'm going to remove that code o2.txt. Remove code o2. I'm removing that file. So if you type ls, I see that it's not there again. It has been deleted. So I'm going to start the syntax all over again. Now I'm going to use the iter and the pbkdf2 commands, the syntax rather. Openssl AES 256 CBC P. You can as well copy and paste it. I just like to use my fingers sometimes. 10,000 123 dash D. The encrypted message is what? Code O2. Do not forget. Code O2. Then we're going to out. Then the original message test. Code o2.txt. Then we are going to press enter. So it's going to ask us for the key S, exclamation mark K, caps lock R, 3, caps lock T, then 55, enter. Oof, please work. Are we having bad decrypts? Let me read. Crypto, what is he asking? What is the third word in the file? So what's the challenge? I don't know what the issue is now. Is it T I used or E? We're trying to decrypt, okay. 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 So bad decrypt. I'm having a bad decrypt. Yes, 256. Exactly what was said. CBC, okay. Sometimes this happens really. I don't know. PBKDF2. Heater 10,000, okay. D in, okay, out, okay. Okay, let me see. I'm sure I have a file like that already. And let me cut code o2.txt. Oh, type kids. Sorry. Sure it's going to be gibberish. What's happening? I really don't know what to do at this point. I'm following the commands. Did I do something wrong? Okay, let's try again. Openssl AES 256. Okay. The right directory. I have the right file. So let me just remove. Let me remove it. .txt. Okay, good. So open SSL. EBKDF ITER, then 10,000, 1, 2, 3. Okay, let's see. Let me remove this 10,000 first. The number of iterations. Okay, 2. Okay, dash D dash N. Make sure it's quote O2. Yeah, it's quote O2. Quote O2. Okay, then we out into quote o2.txt. Are we cool? Are we cool? I'm tired. All right. Enter. We ask for the key. X exclamation mark K shift R 3 shift T 55. Bad decrypt. Whew. I give up. I don't know what's wrong at this point. I'm going to try once more, and after that, just going to leave it. Open SSL. Okay, let me remove the quotes. O2.txt. I'm going to rename instead of using quotes O2. Okay, Control L. ls. Quote O1.txt, quote O2, quote O3.txt. Okay, open SSL. AES 256 CBC. PB KDF2 beta 10,000 1, 2, 3, 4. Good. We are going to decrypt in port O2, then put out. Let's just type out original underscore quotes O2.txt. and press enter. Enter the decryption password. Is this something that has to be my password? Okay. Oh no. I'm not sure I can copy and paste password. S K R 3 T 55. Same thing. At this point, I'm gonna give up. I'm going to remove. Okay. I really wish I knew what is wrong, but code O2. Mm. Mm-hmm. Oh, okay. There was no success here. Remove. I don't know why we're having a bad message, really. Remove. Okay, it's been removed. Okay, let's move on to the next task. We are told to decrypt this file using Camellia 256 with this encryption key. What is the third word in the file? Control. Let me clear my screen. I'm going to come to the decryption code for GPG. So GPG output. That's we're having code 3, right? That's what we want to output. I do code 3 dot tst. Okay. Click this another one now. Okay. Where's my machine? Oh, can I extend? Oh, I'm a free user, so I have just 1 hour. So let's quickly do this. Output code 3 dot tst dot txt, right? Then next thing is the input. So we decrypt. No rush. Enough time. Let's go to O3. Dot txt dot gpg. We enter the passphrase exclamation mark KR35055. Encrypted with one passphrase. Okay. Let's see. We have codes. Okay, so we cut codes o3.txt. Oh shit, I'm in a rush. You must understand that there is more than one part to the top of the mountain. So what is the third word in the file? Understand. I don't know why our Openssl isn't working. If I end up finding the solution, I'll put it in the comment section. So basically, we followed the syntax. The Open GPG is very easy to use and straightforward. You just need to follow the syntax and make sure you have the key. And that's going to be the end of this class. We've looked at symmetric encryption that requires us to use one key to encrypt and also decrypt. And we're having two types. We have the block cipher and the stream cipher. The block cipher encrypts in block and the stream encrypts in bytes. So there are two available and that are widely used for both encryption, for symmetric and asymmetric. And we have the GNU privacy guard that is also known as GPG. And we have the Openssl project. Thank you very much for listening. Have a wonderful night. Bye.